So tests, as far as logistics go, there's 40 total questions. There's 27 multiple choice. And they'll all be worth 2 points apiece. The rest are open-ended, and if it's just one question, like if it's just one part, then it's also 2 points. But the ones that have multiple parts, so like your graphing calculator ones where you have to figure out your regression and then you have to find the regression, each of those parts are 2 or 1 point. When you get to the graphing part and you have to find like domain, range, like all of those things, each of those will be worth more points. So again, like pretty much every blank, I would say, is worth 2 points. There's 11 that use the calculator, and the rest are non-calculator. The calculator ones are a mix between, the open-ended. So we're going to do the same thing we did as the last test that was multiple choice. You're going to start open-ended calculator. Then you're going to go to multiple choice. Then you're going to go at the end back to open-ended non-calculator. So that's where the graphs of the logs will come into play, that kind of stuff. You can go back and forth just like normal. Like if you do the calculator portion and then you go into the non-calculator portion, you can, of course, go back to the non-calculator portion. I don't think timing should be an issue if you know what you're doing. Think about it. You just did a 20-question test in 50 minutes, right? Or in 45 minutes. We double it, but some of those questions are fast. And you have an hour and 40 minutes. So like you will start, when you come in, I'll literally take attendance, you'll start. So you have the whole time. I'd rather you have too much than not enough time, okay? There is nothing on that test that is not in this packet. The format's obviously different because on your packet I didn't give you multiple choice for everything. There are a couple multiple choices, but it didn't give you multiple choice for everything. So I would say that's where it's a little bit different. And then obviously, like there's questions where I gave you multiples of one kind. Like when you get to the rational functions, I gave you a couple different examples. You might get 1 or 2 of those. And they're broken down. So you might get a question that says, here's your rational function. Give me just the slant asymptote. Here's a rational function. Give me just the vertical asymptote. So it's not necessarily all of it in one. Like it'll be broken apart like that. Okay. So I want to go with you. I'm going to go page by page. And then you tell me, 1, if you have a question on this stuff. 2, if that is something that you know you need extra practice on. And that's how I'll build what we're going to do when I see you next. Okay. So let's go first page. Questions on those. 5. So that's good. I feel like these are one of the things that you, between geometric and arithmetic, that you probably, I already have that on my list from yesterday to make sure that we have extra practice for. So you saw these types of questions in 2 ways. One is it flat out told you it was a geometric sequence and it asked you to find a specific term, or it told you it was a geometric sequence, asked you for the formula, or it told you it was an exponential, which I forget what question that is, but I'll say it later, where they give you the 2 coordinate points and they ask you for the equation. So all of those are the same type of question. So for geometric, and this is one of those formulas you need to know, it's A1 times R to the n minus 1. That's how you would find any term in your geometric sequence. What's tricky about these was that it doesn't always have to be A1. We can shift it. If we shift the A1, though, we shift the exponent. So if I use A3, then I do R to the n minus 3. If I use A4, then I use R to the n minus 4, like that. And you don't always have sequential points or terms, and so that you can't find the R. Like if I don't give you A1 and A2, you can't find the R just by dividing. And that's what this question's like. I give you A5 and I gave you A9. So for these, the trick is to put the A with the bigger base on the left equals A with the smaller base on the right, and then R raised to the power of the bigger base minus the smaller base. We'll do the arithmetic one like this because it's also similar, but there's a couple differences. So in this case, the A with the bigger base, not necessarily the bigger value, but the bigger base is A9. So A9 would go here. equals A5 times R to the 9 minus 5. So R to the 4th. So the base on the right with the exponent next to it should add up to the base on the left. So I'd get 2 over 65, 61 equals A to the 5th, 2 over 81 times R to the 4th. I think this question is on, let me check, the non-calculator portion, but your values are smaller. Like you're not going to get 6,000, okay? They're doable. So I would first multiply by the reciprocal, so I multiply by 81 over 2. And then this should always simplify. 2 and 2 cancel out. And then, like I said, it should be more obvious, but 65, 61 is divisible by 81. Oops. 81 times. So I get 1 over 81 equals R to the 4th. And then this style question where it's asking for a specific term, you'll be able to find the actual root. Later on, when I ask for the equation, you'll leave that as a cube root or a square root or whatever it is. So I'll fast forward to that question next. But this, you'll actually be able to find the 4th root. It will be something that you'll know, like a 2 to the 4th or 3 to the 4th, something like that, okay? So R is 1 over 3, because 3 times 3 times 3 times 3 is 81. So if it was asking for the equation, I would use one of the A sub 5 or A sub 9s, and I would do times, whatever that value is, times R raised to the n minus the base. So it would look like this. I would either have A to the n equals, I could use A to the 5th times R to the n minus 5, which would be A to the 5th is 2 over 81 times R, which is 1/3 to the n minus 5. And that would be an acceptable answer. Or I can do A sub n equals A to the 9th times R to the n minus 9. And A to the 9th would be 2 over 65, 61 times 1/3 to the n minus 9. So if the question asked for A sub n, that would be my answer. But this question asks for the 6th term. The easiest way to do it is just it gave you the 5th term. Just take the 5th term and multiply it times R. So my 5th term is 2 over 81. I just need to go one more term after that. So I multiply that times 1 over 3. And I get 2 over 243. And that's the 6th term. So again, you'll get 2 geometric sequence questions, sort of. One that says geometric sequence, find this term. The other one says these are 2 coordinate points on an exponential graph or exponential function. Find an, and then that would look like the one on the left. So I pulled in question 36 because it's similar. The wording is different, but the process is almost identical. So the wording says it is known that f of x is an exponential function and that it passes through the given points. Write an equation for this function. So remember, exponential is very much like geometric. There's a little bit of difference when you graph it because geometric would just be points, but an exponential would be a curve. But other than that, you can use the same formulas. So if it's exponential, and these are my coordinate points, 2, 10, and 5, 4, I can convert that into a sub 2 equals 10 and a5 equals 4. And now I can do what we just did in the other example. I don't know R, so I would find R by putting A with the bigger base on the left, so A5 goes on the left. Then it's A2 times R to the 3rd. And A5 is 4, and A2 is 10. So the X is the base on the A, and the Y is what it equals. X is the base on the A, Y is what it equals. Oh, like the answer at the end? AN is the same for both. The only difference, it's like so if you didn't put f of x, like this actually could have been f of x here. That's actually how it should have been. I won't change that. I won't mark wrong for that. You could put either one. If it was multiple choice, you would know to look for the f of x, that's all. Yeah. All right, so now I got to find R. So I would divide both sides by 10. and I'd get r to the third equals 2/5 once you simplify it, and then I would cube root it. So I get r equals the cube root of 2/5. And normally we would try to rationalize that, but you can leave these as they are. Remember, the end goal here is the actual equation. So that's my r, but the goal is to get to the equation. And you can use either point. I can either use a2 or a5. If I use a2, then I'm saying a sub n equals a2 times r to the n minus 2. I change the exponent to match the base. So I get an equals 10 times the cube root of 2 over 5 to the n minus 2. And then that would be one answer I'll take. And the other one, well, and again, this should be f of x. And then the other one would be an equals, now I'm going to use a5. a5 r to the n minus 5, which would be 4 times the cube root of 2/5 to the n minus 5. And again, you can replace that an with f of x. So either of those answers are right. This is obviously on the open-ended part, no calculator. So that's like one of the ones that you'll go back to at the end because there's two answers. Questions on either of those? I do think it's one of the more complicated kinds of questions. No, you don't need to write both. You can just write one. Yeah. Okay, so for number 1, it says divide synthetically. The first thing you got to do is make sure it's in decreasing degree order and nothing's missing. So if it said 4x to the third minus 8x plus 6, you have to make sure you add in the 0x squared. So if you're missing a term, it has to be added in. In this case, there was no missing term, right? So it's negative 10x to the second minus 8x plus 6. And then divided by, it was x minus 3, right? Yeah. So you list all the coefficients of what you're dividing into, so the dividend. So it's 4, negative 10, negative 8, and 6. And then you put the opposite of what follows x out here on the outside. So 3 goes there. Bring down the 4, multiply it by 3, and put it in the next column. So it's 12. And then you add those. And then you multiply it by what's on the outside, and you put it in the next column, and you add those. And then you multiply it by what's on the outside, you put it in the next column, and you add those. The last term is your remainder, and it might have a remainder. This one didn't, but it might. If it does have a remainder, you put it over the divisor. So I would have put it over x minus 3. And then as you move from the last to the left there, this one stays as your constant. This one gets the x. This one gets the x squared. If there was another term, it'd get x to the third, and so on and so forth. So this is 4x squared plus 2x minus 2.
So how do you put the remainder on that?
If there is no remainder, you leave it off. If it said, like, when I added those, I got 3, I would say plus 3 over x minus 3, like that. Yep. Oh, no, I mean, you do when you just divide. You don't, the only time you don't use it is when we do slant.
Yeah.
When we don't do slant, we ignore it. But typically, if it has a remainder, we include it. Thank you. Other questions from this page? Okay. Then after that came arithmetic. So arithmetic is another formula you need to know. A(n) would equal A1 plus D times n minus 1. And 6 says find the formula for it. And it gives you A1 and it gives you A5. So there's 2 ways to find D when you're not given sequential terms. One is use it like slope. Do A5 minus A1 over 5 minus 1. So it'd be 15 minus a negative 4 over 5 minus 1, which is 19 over 4. And that is D. The other way is use the formula kind of like we did with AR, where A with the bigger base goes on the left, equals A with the smaller base on the right, plus the difference between big minus small times D. So in this case, you've got an A1 and an A5. I'm going to put A5 on the left, A1 on the right, plus 5 minus 1, so 4 times D. And then A5 is 15. A1 is negative 4. Add the 4. I get 19 equals 4D. Divide by 4. And D equals 19 over 4. Sorry? Yeah. And you could choose. Like, I think the top one is easier because but it only works arithmetic, so you can't use that method for geometric. You're just find the slope. Like, you can even rewrite these in coordinate point form. Like, A1 equals negative 4 is really 1 comma negative 4. And then the second one, A5 equals 15, is really just 5 and 15. And then you can find your equation using point slope. Like, you could do it any of those ways. I will say that this one's multiple choice. So all we did was find D so far. We now have to find the equation. And there's 2 ways to write that equation. Only one of them is going to be there. So just make sure if the first way you do it is not there, that you keep going to try to find the other one. So I'll kind of like show you specifically what I mean. But I have D now. I need to find A1 plus D times N minus 1. A1 is negative 4. D is 19 over 4. If you stop here, your answer is not going to be there. You have to keep going. So I would distribute this negative 4 plus 19 over 4n minus 19 over 4. And then you got to combine these. So 4 over 1 becomes 16 over 4. And you get negative 35 over 4 plus 19 over 4n. And it's going to say an equals that. So don't panic when you get here and you don't see your answer. You just got to distribute the 19 over 4. Questions? All right, so 7, 8, and 9. 7 gets you all your asymptote stuff. So this is when I was talking before that it's not going to ask you for all of it in one question. It's going to ask you for parts. So it might say find the zeros. It might say find the vertical asymptotes. It might say find the horizontal asymptote. It might say find the slant asymptote. It might say find the whole. The whole has to be done in limit notation, so make sure you know how to find a whole in limit notation. Oh, actually, this is wrong. So this should be as it approaches. That's the end behavior. I put that the whole would be the limit as your x approaches the x coordinate of your whole, which is negative 5. Oh, that's hard to read.
How do you know the coordinate of the whole?
So whatever you cancel out, like in this example, did I change that bottom one to 5 on yours? Dang it. Okay, so add this one because there was no hole in yours, right? Add an E because that has a hole. And then we'll talk about how that changes it. Okay. So when I factor this out, I get x plus 1 times x plus 5 over x plus 5. And the x plus 5s cancel out. That's when the whole is formed. The whole is, if I set that equal to 0, I get x equals negative 5. That's the x coordinate of your whole. And then to find the y coordinate of your whole, you have to plug that negative 5 back into your updated equation. So now my equation is just f of x equals x plus 1. I'm going to plug that back in there. So negative 5 plus 1 is negative 4. And that's how I know the y coordinate of my whole. So then the limit notation on the whole is the limit as x approaches the x coordinate of the whole from the left. So it'd be as it approaches -5 minus, and as it approaches -5 from the right. So on both sides, it's coming towards the whole. Both of these f of x's equal the y coordinate of your whole. So the only thing that changes is that little plus or minus. That's it. So like that question's worth 4. I gave 2 to each of those blanks, I think. Questions on any of the other like rational function stuff? Okay, then comes your binomial expansion, and it says a specific term. So I don't really want you to waste your time expanding the whole thing. You might have time to do it, but it's a waste of your time. Remember to just figure out your pattern. So if it's to the 10th, there's going to be 11 terms. You certainly don't want to find all 11 terms. If n is 4, we're talking the 4th term. 1, 2, 3, 4. Then the first term, remember we start at the 10 and we work its way down. So the first term would be x to the 10th, then x to the 9th, then x to the 8th, then x to the 7th. And the second term is the opposite. The second term starts at 0 and then goes up to 1 and then 2 and then 3. And then you need your binomial coefficient. So Pascal's triangle, I didn't give you one that has 10. Again, it would take you forever, but. $21.35. And I really only need the 4th one, so you don't have to keep going. 1, 8, 28, 56, 1, 9, 36. 84, 1, 10, 45, 122. Is that right? That looks weird. 120. Duh. Thank you. I'm like, that math is weird. Okay, so that's the one you're going to grab. And that would get multiplied times the front here. So it'd be 120, x to the 7th. And then this would get distributed, so 8, y to the 3rd. And then I would do 120 times 8. No, I think I gave you like 6, maybe. And that's on the calculator part, just because those numbers, like when you multiply them out, can get big. Are we good on 9 and 10? Just know the shape of your graph. Just 9. Okay, so because it's got a 0.5 base, it normally would be decreasing as you move to the right, right? And then the negative on the front says flip that upside down, so it's going like this instead. So that overall shape is increasing as I move from left to right, and it's concave down because it would take on that curve shape. The negative on the front is what flips it upside down. And it's not like you're going to get 2 of those. You're going to get 1 of those.
So if it's greater,
If like the base here is bigger than 1, now you're increasing because you're getting bigger. Yep. But it could have a negative on the front and be like that. Now you're going like this. So just be careful. Yep. Correct. Yep. All right. How about these? So these are just like not 14, but 11, 12, and 13 are all open-ended like that. Okay, so 11, if you think about it, like it has 2 parts. Each of those parts will be worth 2 points. So 2 points for the first question, 2 points for the second question. Whereas number 12, like, I don't know if I gave 2 points to domain and range, maybe. If not, it will split between those. And then 13 would be 2 points. Yeah. Did I? I sure did. That's 14. That's 14. Thank you. Any other questions on these? So non-calculator, all of that's non-calculator. And then even and odd, remember you're looking, if it's even, it's symmetric to the y-axis. So if you're looking at a graph, you could fold it on the y-axis. If you're plugging in values, then if I plug in a negative x into all the x's and it goes away, that's even. If I plug in a negative x and they all change signs, then it's odd.
And it's neither if they don't.
Correct. Like B, the first one changed sign, but the second one, the sign went away. So it's neither. That one's, I mean, I gave you like, it's multiple choice because it says even, odd, or neither. So it's like that. So 11, in the beginning it says,
It's just 5 hours now.
yeah, you got to know to plug it into that one.
Just plug it in.
Yep, you just plug it in there, and then the rate of change, we do f of 1 and f of 3. So you have to find f of 3, you have to find f of 1, and then you put it over 3 minus 1.
That's not gonna be calculated.
That won't be calculator based because the answer should be easy. Yeah, and if it's not like a whole number, you can leave it as a fraction, but that's not calculator based because otherwise you could just type that in. Any other? So 12 says it has a domain of -1, 5, and then a range of 1, 8. And then you're dealing with all your transformations. So if it says 4, f of -x plus 2, the 4 on the front is a vertical stretch. So this, you change your range, right? Because vertical would be the y, and that's your range. So I'm going to multiply my range by 4. So 4 times 1, 8 would be 4, 32. The inside the parentheses affects your domain, so I'm going to come back to that in a second. The outside the parentheses over here also affects your range because it's a shift up 2. So now I'm going to add 2 to these. So I get 634, and that's the range. The minus inside, or something if you add or subtract, the horizontal shift, all that stuff's going to affect your domain because that's horizontal, right? The negative on the inside literally just says take your domain and flip your signs. So the domain -1, 5 would become 1, -5. And then because it's interval notation, the -5 has to come first. So we have to switch it. If it had said x plus 1, then I would take my x and I would shift everything left 1. If it said x minus 1, I would take my x's and I would shift them all to the right 1.
And then if there's a number like inside, like how you did vertical stretch, if it's like a 4 inside, you just multiply by it.
Correct. The x values. Yep. So I start with the inside of the f, and it says find g of 1, so I'm plugging 1 in. So the first thing I'm doing is finding 2 times 1, which would be 2. So f of 2, I go to where x is 2, and I get that value. So f of 2 is -1. And then I have 1/2 times -1 plus 4. -1/2 times 1, -1, sorry, is -1/2 plus 4, which is 3.5.
And you already made it here. Why just making extra practice on that?
Yeah, they asked me to do a couple extra questions on that. Yep. All right, 15. Now you're doing the inverse. This inverse would be an open-ended question. And you're only going to get one of those. It's not like you're getting both, but it could be either one. And 16 is open-ended calculator question. And 17. I actually think those, like, that is number 1 and number 2 on your test. Like, how that is how they'll start. The open-ended and calculator ones. So there's 11 calculator questions. Some of them are multiple choice and some of them are open-ended, but you'll start open-ended.
Okay, are we gonna have to write it in R squared?
Yeah.
I
Well,
just
you don't
did it
have to
help
write
me,
it in.
But is it gonna be like one of the answers?
No.
Okay.
No, it literally looks just like that. Which one is the one that works? Find the model and then do something with it. And then 17 just like that. Which one is the works? Find the model, predict something, compare. And I will say I'm gonna nitpick. Like literally that line is worth 2 points. So maybe I'll take 1 point off if you don't include the units, but you should use those units. So at specifically the input value, the model underestimated or overestimated by, and you need the certain amount.
Also, what's what we have to change to get the R squared?
So I'll remind you, but you'll reset your calculator and then you'll turn on your stat plot and then you're going to go to mode and put your diagnostics on.
So can you keep that on right now?
The stat diagnostics. But I promise you I'll remind you.
Does that affect anything? Can you keep that on the whole time?
You can keep it on the whole time, but when you reset your calculator, it goes away.
Oh.
So like, I'm going to make you reset your calculator, it's going to go away and then you got to turn it back on again.
Number 8 is why is it
So if I plug in a negative x, and then I plug in I don't know why I put that in parentheses, but negative x again, the odd changes that sign. And then this is positive 3, but this odd changes that sign. So this is negative 5x minus 3x to the third. They are both changed, which means it's odd. The other one both changed, one only one changed. Yep. Okay, then you get your rate of change. So 2 questions on the rate of change I think were like this. One is where you have an equation like that, where you actually have to just like, take this, plug it in, take this, plug it in. You are going to get your calculator on that question. So if you want to store y equals 4x squared minus 3x plus 2, then you can type it in the calculator like this. So that's why I worked out both, because you can do it both ways. You could literally plug that value in and solve it arithmetically and then find the difference. Or you could literally store that in your y1 and then do f of 1 minus f of negative 5 over 1 minus negative 5. All right, then you had your inversely proportional. Good on those? Yeah, okay. Appropriate or not appropriate. Remember, you're looking for a pattern. When it says justify your answer, make sure you say because it's got a pattern or because it doesn't have a pattern. Don't just write appropriate. 22 is like describe your end behavior. So you remember your rules for end behavior. If your variable, if it's a positive with an even exponent, then it increases on both sides. So my limit notation would be that it goes to infinity on both sides. As x approaches negative infinity and as x approaches positive infinity, they both go to positive infinity. If it's a negative x with an even power, now they both point down. So they both decrease without bound, or the limit notation, it would go to negative infinity. If it's positive and odd, it goes down to the left and up to the right. And if it's negative and odd, then it's up, left, down, right. I think I gave you like 1 expansion, 1 condensing for the logs. And then there's the stuff that you're solving, like the ln's and all that stuff. That's on the calculator portion.
So we have to write it as output increases.
Well, that question will be multiple choice.
Oh.
So you just got to read the wording.
Okay.
Yeah.
But will it have it in terms of output or no? Output.
It'll say as the input increases without bound, the output does
like-
what? As the input decreases without bound, the output what?
As the x increases.
So it's going to say input, not x.
Oh, okay.
Yep.
Okay,
Does that make sense?
Yeah.
Okay.
Wait, can you go backward?
All right, good on exponential and log graphs. So this is like this part, it's like I gave 2 points to that, I gave 1 point to that, I gave 2 points to that, I gave 2 points to that, I gave 2 points to that. So that question in its entirety is worth, 9 points, but it's broken down between those points. Yeah.
Is everything on the midterm gonna have that range, or is it gonna like?
Well, exponential functions wouldn't have that range. Is that what you mean?
Yeah.
Anything that's log or ln has a range that's negative infinity to positive infinity. Yeah. If I ask for the domain and range of this, my domain would be negative infinity to positive infinity. The range would be from the horizontal asymptote, which is at 2, to positive infinity. So they switch exponential. I kind of think a log is the only one I asked the range on. Yeah. All right, then you get a question like this. So this one's same, like each of those lines are 2 points. So in its entirety, it adds up. Maybe I did 1 point each one. But so that question itself looks like it's worth a little bit more, but it's really just, you can get 1 part right, 1 part wrong. So be careful. I would say the point of inflection, this question on your test actually has coordinates, like it has a grid. So the point of inflection, you'll be able to give me the coordinate point of. It will be a value like 1, 2, or whatever it is. You'll give me the actual coordinate point there. And that goes back to, so that's at the end of your test. Open-ended without a calculator. 27, 28, these are all calculator based. So these are going to come like at the beginning of your test, because that's when you have your calculator. And then the rest of them don't. So for something like 20 or 31, don't forget your lower bound, because it's open-ended, so you're not going to see it. Like, don't forget that those ln's have to be greater than 0. That's how you get the 26 over 5. Questions on any of those? All right, this one. So again, this would be at the beginning because you need your calculator. You'll do the log, you'll find the regression. You can either find the regression algebraically by logging both sides, or you could find the regression on your calculator, or you could do both and check if you've got the time. Something like 34 calculator based, obviously 35 you're describing transformation, so be prepared for any kind of transformation. Vertical, horizontal, compression, stretch, over the X, over the Y, make sure you know the difference between those. 36 is the one we did at the beginning, and then 37 you're literally just plugging in. Like if you get to a one that like throws you or frustrates you, move on, find something easy and build your confidence back up and then go back to it. Questions for me? Okay. So we talked about what do we need? We need extra practice on geometric, arithmetic. What else? I made a list yesterday.
Can you do more examples of like the per and like the per and like
Sure.
half-life?
Like half-life, all that stuff with the value given, and then also when will it happen?
Yeah, like-
So when you're plugging in or set equal.
where they give you like a table and it's like, this is f of x times g of x. Do you know what I'm talking about?
The log one, this guy? No. Oh, the ones where I gave you the table and you had to find the inverse, or you had to find, and then you had to do 1/2 f of x. Yeah, okay. Like a big guy at the beginning. Yeah. Okay, table from beginning. Yeah. Okay. What